This is Dr. K. Sravanthi, working as an associate professor in the Department of Mechanical Engineering at Marri Laxman Reddy Institute of Technology and Management. Today, I take this opportunity welcoming you all on the course Computer Aided Engineering Graphics. Well, moving on to the course, let us understand what is engineering drawing. So, before we get into the major subject, today's contents would be the outline where we would discuss about the introduction to engineering drawing, what is its importance, then what would be the difference between engineering drawing, engineering graphics, and some of the contents like lettering, dimensioning, and also an introduction to AutoCAD. Well, let's begin today's session. What is drawing? Well, from kindergarten, everybody is used to this particular subject, which is drawing. When we talk about this, drawing is a pictorial representation of an object, right? Isn't it? Well, look at the slide. We have two images here. This is image number 1 and this is image number 2. Now, what would be the basic difference between these two images? The first image is all about a sunrise or a sunset. There's not much clarity in that. Okay, then moving on to the next image, there is some detailed description of some engineering item. So now if we get into the details, like what is engineering drawing? As told earlier, drawing is a pictorial representation of an object. Okay, now for example, if somebody is asking me to draw a star, right? This is a star, right? And maybe some other person can also depict a star like this. There is a representation in 1 as well as 2. So definitely when I see the word star, okay, that has pictorially represented here in different means. So this is just a drawing, what you see in figure number 1. So my perception is different from the other. So drawing is just repeated once again, a pictorial representation of an object. But in this case, when we are adding some standards to that particular drawing, then we call it as an engineering drawing. So let us get into the details, like what is engineering drawing? Well, it is stated very clearly that engineering drawing is a technical drawing, right? So now if you look at the world, it is 99% filled with products. You pick anything, right from the pin what we use, the computer on which we are working, the camera which is focusing on me, right? You pick any product. Before the product is launched into the market, it accumulates many processes. The very first one is idea generation. After the idea has been generated, right, definitely we talk about the design, right? Without any design, it is highly difficult to put the product, to put the material together and then launch the product into the market, right? So this transformation of an idea into a design can also be called as a drawing, right? But if this is something related to an engineering application, let us say a building need to be constructed, some equipment need to be designed, some automobile engineering engine need to be designed, some gear has to be produced, some wristwatch has to be made. Now, what is happening here exactly? There is an idea which is generated somewhere, and this idea is transformed into a design, right? So this design in brief can be called as an engineering drawing. So let us go through the definition here. So it says that engineering drawing is a technical drawing, right? When I say technical, it is related to the engineering items and it gives you the entire requirements of the item what to be produced. Let us get back to the previous line. Now, if we look here, there is an engineering item, right? And all the details are clearly specified if you look into the diameter or height or depth, because this gives an engineer at the production side how to exactly make a product. So now when all the details are mentioned in the drawing, to keep it more specific, that we call it as an engineering drawing, right? Okay. There is another definition. We can say that engineering drawing is the language of all the engineers. It is the language of all the engineers. So, what is this language? We are using engineering drawing as a language to share the ideas or some information or some concepts which are related to an engineering items, right? Say, for example, a bottle need to be manufactured in a pharmaceutical industry, which is accommodating a 10 ml of syrup. Now, this idea, when it is put on a paper or on a computer, it is clearly mentioning all the specifications, and that becomes a language. Okay, there we going to share this information to the production side, and therefore we can say that this clearly, bridges the gap between the production as well as the design department. So now here we are saying that it is exclusively used to communicate ideas, concepts, as well as designs. Now, when we get into the depth of this, it is a universally accepted language. Now, we do it in India, somebody else is doing drawing in Australia, or somebody else from Germany, right? Who else does it? It is all standard. Means I do it, somebody else is doing it, it will be one and the same. So, drawing is a standardized language. To be more specific, engineering drawing is a standardized language. At the same time, as told earlier, it is a universally accepted language, just like English. English is understood globally, right? Therefore, engineering drawing is also understood globally, and therefore, any engineer from any nook and corner of the world can easily understand when the concepts and ideas are shared, right? So, moving in detail, right? So, what are the objectives of this engineering drawing subject? Now, this is one of the subjects which is introduced in the BTech curriculum in the first year, because people and students, students from different streams need to have an idea about it, because in near future they will be working in an organization where all the engineers come together, and that is what it is told that it is acting as a language between all the engineers. So, right from idea generation to as well as the production, right? So, now that is what told here. It is a universal language, right? Any different kind of complex design, let it be related to any of the sector, maybe mining, mechanical, civil engineering, pharmaceutical, you name it, any ideas, let it be any complex, there would be a clear communication between the engineers. Then, whenever this idea is communicated, there would be a good amount of accuracy as well as precision. Errors can be minimized with the help of engineering drawing. And as told earlier, yes, it is a standardized language. We Indians, we follow Bureau of Indian Standards in order to make a drawing of any engineering items. If it is somebody from America, they follow the American standards, right? Germany standards, and Australian standards. So every country have their own standard, but just like E is equal to mc square, universally accepted. Well, in similar way, engineering drawing is also universally accepted worldwide, right? And when we convert this idea into a design, it becomes very easy for us to document it. So therefore, definitely there is going to be a formal record of any design and specification. And in future, if you want to make some modifications to that particular design, or maybe something else to be added to the existing part, this document will really help in making those required changes. So this also helps in documentation. And definitely there will be an 100% efficiency. So now when a person is explaining about a product to another person, maybe from a designing engineering department or to a production department, not all the terms are understood. Definitely there would be some ambiguity. But when a design, or let us say some drawing with all the specification, is communicated on a paper or on a computer, then there is no confusion. It is quite crystal clear. Therefore, 100% efficiency is possible And that is one of the objectives of engineering drawing. And any kind of problem can be quickly solved. So within very less time. So this is also one of the important objectives of engineering drawing. Well, now, if we look into the title of the subject, it is told as Computer Aided Engineering Graphics. Now, there are two terms what we see right now. One is graphics and the other is the drawing. What would be the difference? I have been speaking about engineering drawing and now suddenly we say that it is engineering graphics. What? How do we differentiate both of them? Now, engineering drawing is a manual drawing. Okay. In order to do this, we use certain instruments like drafters, pencils, compass, protractor, scale, and many other. And all the drawings are done manually by a person on a piece of paper. When I say this, yes, definitely it also includes standards when you choose the instruments or pencils or protractor or whatever it might be. But the point to be remembered here is that it is manually put on a paper by a person. It is engineering drawing. Now, when we look at this word, which is graphics, so this is all about the involvement of a computer in drawing. Here, we are taking a help of a computer and then we are making some drawings on a system using some software. Then we can call it as an engineering graphics. So to name, what we do is that there is a software which is called as AutoCAD, or you can also call it as 2D, 3D visualization. So with the help of these softwares, we are making a design on a computer which is termed as engineering graphics. So, which reduces your time, documentation is more efficient, okay? At the same time, you don't, require so much manpower and your drawings are to be, will be visualized in a very colorful and precision manner. So, there are few advantages of graphics over engineering drawing. So, this would be our major session where in future classes we will talk about AutoCAD, a software, and how this software is used in making some designs on a computer in relation with engineering drawing. So, engineering drawing is a narrow subset of engineering graphics. So, this slides basically speaks about the differences between the engineering drawing as well as the engineering graphics. So, moving ahead, as of now, we have understood like what is drawing, which is a pictorial representation of an object. Then what is engineering drawing? Drawing of an engineering items which is standardized is called as engineering drawing. This is a universally accepted language. This is exclusively used in sharing the ideas as well as concept among the any engineering background, right? And moving in depth, if we are taking help of a computer and some software and we make some drawings on a computer, then we call it as an engineering graphics, right? That was the introduction. So moving on to today's session, let us start it with the very first topic, which is called as lettering. Okay, before I get into the basic subject, now every person, okay, is given a name, right? Okay, we have a surname, we have a full name, and we sometimes call it as an original name and a pet name. So, why are humans given a name? In simple, identity. Your name becomes your identity, right? Similarly, every drawing has an identity, right? So, here when I say lettering, lettering in simple terms is giving a name to a drawing. So, how do we do that? Definitely, there should be some language, right? So, what language are we using then in order to give a name to a drawing? Is it mother tongue or something like Telugu, Hindi, whatever it might be? So, definitely no. We have picked up a global language which is called as English. So English is a medium through which or with the help of which we are going to give some names to the drawing, right? So let us get back to the definition. So lettering is giving a name to a drawing. So how do we do this? Now, when I say name to a drawing, right? Okay, it can be categorized as title, subtitle, okay, description of a drawing. So you pick any object. Okay, you pick any object. This object will have a title, it will have a subtitle, and then it will have some description, right? These all are included in lettering, right? Okay. Now, for example, let us say there is a material. Okay. The name of the material is the title. Which category it belongs to is a subtitle. The information about its microstructure, its properties, where is it applied, it all falls in the description. This entire information is called as lettering. Okay, right. Now, how do we give lettering? Okay. Now, this lettering, as told earlier, we're going to use the language which is English, right? Okay. Now, English. So, while we are doing this lettering, there are different types of lettering. It can be called as single stroke lettering or Gothic lettering or italics. Depending upon the necessity, okay, we can pick any different types of lettering which is specified here. But when it comes to the students, okay, we usually concentrate on single stroke lettering, right? What do you mean by single stroke? Now, if I write a letter A, okay, and let me write a letter A. So, if I'm maintaining the thickness of the line throughout its writing path, then it is called as a single stroke. It does not mean that you have to write the letter without lifting the hand. It means that now this letter A is a combination of many lines here, 1, 2, and 3. All the lines fall in the same width. So then we call it as a single stroke lettering. Italics, we have an idea, we use it in a Microsoft Word. They are slant, okay, at an inclination of 30 degrees to 45 degrees at certain inclination, right? So getting into the details, so how do we do this lettering? We know very well, in case we need to write some letters on a paper, we require pencils. The manual tools are pencils, and there will be certain templates, which I would be discussing in a couple of minutes. Or if it is an engineering drawing, we make use of pencils and paper and certain standards, the English language, A to Z letters, 0 to 9 numbers, uppercase and lowercase a to z. These are generally used. Okay, right. When it comes to the software, definitely you will have certain commands which are like text command, with the help of which you can automatically type the letters. You can give certain standards and then you can write your text. That we will do it in the later part of the lessons, right? So when we are doing lettering, it is not like simply we write, if for example, I'm supposed to write A, P, P, L, E, apple. You have to understand here that my handwriting does not coincide with yours, right? You have, or else let us say there are two people, X and Y. X has a different style of writing and Y has a different style of writing. But as told earlier, engineering drawing is a standardized language. So even when I write something and some Y is writing something, it should look like one and the same because it is a universally accepted language. That is the reason we are using not only English, but we follow certain standard practices so that whoever writes it will come out in a same fashion and it would be very clear to the layman, right? So that should be the importance. Then moving on to the details of it. Now there is a template which is shown here. Okay. Now it is a representation of alphabet on a graph paper where we will focus. It might be a little bit complex when you look at this, but in the further classes, it would become very simple. Right. Now, let us take some letter A. If we focus on this A has certain width, right? It also has certain height. Okay. And when we are writing some alphabets, there is a small inclination which is mentioned here as 90 degrees. So when we do lettering, there are two important parameters. One is the height of the letter and the other is the width of the letter. Generally, the width can be half of the height of the letter. In general, in terms of engineering students, you can pick the width as half of the height. For example, if I say 4 is the height of the letter, 2 can be your width. Now, what is 4? What is 2? Definitely comes units here. So, engineering drawing is a subject which has certain specifications, certain measurements. So, all the measurements or units are in terms of millimeters, mm. We follow standard, which is mm. So, if I say 4 mm is the height of the letter, 2 mm is going to be its depth. So, accordingly, you can write the alphabets. This is a general practice. The very first session, the students have to do this on a graph paper, and this can be explained. So, it's very simple, right? So, this is all about the lettering. Right. So as of now, we have covered what is engineering drawing, difference between engineering drawing, graphics, and giving a name to a drawing, right? So giving a name to a drawing includes titles, subtitles, as well as certain description. Very well. Now, let me take a bottle or let me draw something here. Everybody knows that this is a polygon, which is of 4 sides. All sides are equal. So the title can be given as a square. So let us give some name to it. I call it as a square A, B, C, D. This is lettering, giving a name to a drawing, or I write it as square, right? This I can call it as lettering. Then, what is dimensioning? Right? Now, say for example, I ask you to draw a circle. Right. This is the circle. Somebody else can draw a circle like this, or maybe you can make it more big like this. So there's some ambiguity in the question, some confusion. If I say draw a circle whose diameter is 50 mm, 50 mm. So diameter is 50, radius can be 25. So you can use an instrument which is a compass, what we have used in the 10th standard, and taking the radius as 25 or diameter as 50, and then we have drawn a circle. So some X is doing it or some Y is drawing the circle. It is one and the same. So what is that we have to concentrate on this? This circle is given certain specification, and that specification, which is in terms of diameter or radius, is called as dimensioning. So the specifications which are given to a drawing, so let us say it can be the length of the drawing, the width of the drawing, thickness or radius, or maybe the center, some other locations where you have to place some objects. So all the details are, or all the details have to be clearly mentioned. So mentioning the specifications or the details of the drawing is called as dimensioning. Because when we make up a product, okay, right, let me give another simple example. When we purchase some clothes and visit a store, we not only look at the fabric, the color, okay, the brand, but still our concentration is on the size of the shirt which we are going to purchase. It can be small, it can be medium, it can be XL or L. So this is the specification what we are looking at, what exactly we fit into. So this is a very simple example which can be taken for dimensioning, right? Okay, so now if the dimensions are not clearly mentioned, even if there is 1 mm difference, okay, in the product what we're going to be manufactured, it will be rejected in the quality inspection. So the dimension has to be clearly mentioned, and therefore it is really important. It's really important when we make up some engineering drawing. Okay, and when these dimensions are clearly mentioned, the person in a production department, it becomes very easy for him or her to understand the design and manufacture the product and to complete it accordingly. Therefore, the quality is maintained, right? So, how do we do this dimensioning? There are certain key elements which need to be focused. Okay, let me take up the same example. Anyway, some of the key elements are listed here: dimension line, extension line, arrowhead, leader lines, as well as text and numbers. It might be certain difficulty when you look into this like that. Let me simplify this and make it easy. Okay, let me say there is a square. Let us take a simple example, right? Okay, this is a square. As soon as, let us say, or else, let me take up a question like this. Draw a square of side 40 mm. Okay, the more details, okay, how it need to be done, how can it be done, that we will take up in the upcoming classes. But as of now, let us look at this very simple example. Draw a square of side 40 mm. Let us stick on to the topic. We are only concentrating on dimensioning. Okay, now our intention is to draw a square whose side is 40 mm, right? Using some instruments, okay, maybe a drafter, or you can using pencils, okay, scale, or using the software AutoCAD. Let us say we have drawn a square. So the solution is obtained, right? Then after the drawing is completed, the very next step is lettering. What was lettering? Giving a name to a drawing is called as lettering. So A, B, C, D. In general, you can use uppercase letters A to Z or lowercase letters A to Z and numbers 0 to 9 in lettering as per the standards mentioned earlier, where where width is equal to half of height, right? Okay, the lettering is done. So now if we look into the square, draw a square of side 40 mm. Sorry, question. What is the answer? The square is the answer, right? We have drawn a square. We have given certain name to it. What is that it is actually mentioned here? The side of the square has to be 40 mm. So if we are not mentioning this 40, then there is some confusion. The square is drawn, is it 20 or 30? It's not clearly stated. So how to show this dimensioning here for the square? Now, see, when we get back to the previous line, there are certain key elements like dimension line, extension line, arrowheads, leader lines, text numbers. This I would explain here. So the very first one, we call it as projection lines. Okay, now you have to understand that here AB is equal to BC is equal to CD is equal to AD is equal to 40 mm. So you pick any side of the square that is equal to 40. Means the distance from A to B is 40, B to C, C to D and A to D is 40. That we have to show it here. So now here if I want, now we have to accept that all the sides are of equal dimensioning, which is 40. So indicating on one side will be more than enough. So let me pick a side which is CD. Okay, so what does projection line mean? Projection lines will indicate the end part of the dimensioning, means from C to D, it is 40 mm. So what is the end point here? Okay, one end of the line is C, so the other end of the line is D. So at C, draw a line which is absolutely perpendicular to CD. What is the other end from C to D? It is 40, right? So get back to D, and at D, draw a line which is absolutely perpendicular to CD. What should be the length of the line? Approximately, you can keep it as 8 mm, right? So these two lines which are drawn at the endpoint C as well as D, they both are perpendicular to the actual line. See, now this is the actual line for which dimensioning need to be done, CD. So these lines which are drawn at the extreme ends, we call it as a projection line. Second element is dimension line. So what is a dimension line? The line which is drawn absolutely parallel to the actual line, means look at this line CD and look at the line drawn which is right away in between the projection lines. They both are parallel to each other. The length of the CD is also equal to this line which is drawn parallel to it. It is also 40 mm. So this line is called as a dimension line, and this will indicate the length of the actual line, right? You know, this has to be parallel. What should be the distance? It should not be too close and it should not be too far. Here also the distance can be maintained as 8 mm, right? And third one is arrowheads. What are arrowheads? Arrowheads, for example, there is a line. Arrowhead is a closed filled in triangle of ratio 3:1, which are drawn at the extreme ends, which are indicating the length. Now, here, take a small base, draw a pointed arrowhead which is facing outward to the projection line, and with the other side also draw the same triangle, isosceles triangle, which is pointing outward. Now here, this tells you that the extreme ends from this end to the other end, from this end to this end, the length is 40 mm. So the arrowheads, okay, basically they have to be an isosceles triangle. If the width is 1, the slant height has to be 3. If it is a very big line, the length of the arrowhead has to be big. If it is a very small line, the length of the arrowhead decreases. So depending upon the length of the line, the size of the arrowhead is determined, okay, right? They have to be pointing outwards and both the arrowheads have to be of equal length. And then finally, your dimension value. So what is the dimension value? Look into the question. Draw a square of side 40 mm. So here the side is 40. So now here what we can do is that on the top of this dimension line, write the number which is 40. Write the number which is 40. So it is clearly indicating that the length of the line CD is 40. So this is the dimension value. The dimension value always has to be written on the top of the dimension line, leaving some gap of 2 mm. Or else there is another way of notation. What you can do is that you can draw a line, leaving some space in the center, the dimension line, then arrowheads pointing outward. Then vertically you can write the value which is 40. Right? So this is the other style of drawing. Okay, one is unidirectional, other one is the aligned system. So any of the technique can be followed in doing dimensioning. The same is explained here. We have an arrowheads on either sides, which is 3:1 ratio. Okay, these are the extension lines or the projection line and the dimension line as well as the dimension value. Right. That was today's session on Introduction to Engineering Graphics. Well, before I conclude, today we spoke about the Introduction to Engineering Drawing and what was the basic difference between drawing as well as graphics. lettering, as well as dimensioning. In the upcoming classes, we will have an introduction to AutoCAD and proceed with the remaining modules. Thank you.